Hey everybody, this is a review for your Unit 5 test, which will be tomorrow on Tuesday. So what I'm going to do is I'm going to briefly explain what each of the questions is asking, and then I'm going to ask you to pause the video, try them yourself, and then replay the video, and I'll have the solutions appear. So in 1 through 3, it says classify if an expression is a polynomial. If it is a polynomial, rewrite it in standard form. Then state the leading coefficient, the degree, the number of terms, and classify it. If the expression is not a polynomial, simply answer no and say why it is not. So let's recall how to realize or recognize a polynomial. So a polynomial is a sequence of terms or series of terms that are separated by plus and minus, where the variables have exponents, positive integer exponents, and the coefficients are all real numbers. So the coefficients, or the numbers in front, have to be real, and the exponents all have to be positive integers, so numbers you could really count on your finger. The leading coefficient, standard form, is when we arrange those terms from highest exponent to lowest exponent. The leading coefficient then is the number in the front, so the big number in the front of the variable. If you don't see one, if it's just an x cubed, for instance, like it will be here, then that coefficient's 1. The degree is the highest exponent when it's in standard form. The number of terms is how many terms are separated by a plus or a minus. And then classification is based on the number of terms. If there are 2 terms, you call it a binomial. If it's 3 terms, that's a trinomial. 1 term, a monomial. And then really anything over that, any 3 terms, we call a polynomial. So go ahead, pause this video and try 1 through 3, and then replay the video when you're ready to see the answer. All right, so hopefully you had a chance to do 1 through 3 and hear your answer. So number 1, it is a polynomial because all of the coefficients are real numbers. We don't see any i's. And every exponent is an integer. Like this is to the 3rd, this one's to the 1st, this technically is to the 0. So in standard form, I go from highest exponent to lowest, so the x cubed term is first, and then the 5x is next, and last the constant of 4. The leading coefficient is the number in front when in standard form, so here that's 1. The degree is the highest exponent, so 3, and then the number of terms is 3. And here, 3, because x cubed is a term, 5x is a term, and 4 is a term. What I classify this is cubic because the degree is 3, and trinomial because we have 3 terms. Number 2 is also a polynomial, even though it looks funny. In standard form, the x squared has to come first and the constant second. The leading coefficient here is just pi, so 3.14. The degree, or the highest exponent, is 2. There are 2 terms, and I'm going to classify this as a quadratic because of the square, and binomial because there's 2 terms. And then finally, number 3, is not a polynomial because this last term, I have it circled, has an x in the bottom. And remember, when there's an x in the bottom, that means it has a negative exponent, and our exponents have to be positive. So let's go back to the next couple and look at the directions. So 4 and 5 say evaluate a polynomial for the given value. And how we do these is we simply just plug in the x value for all the x's in the polynomial. Or you could do the synthetic substitution, that fancy substitution that I showed you in class, and still get the right answer at the end of that process. It's always the last number. So pause the video again, and then when you play, you will see the answers to 4 and 5. All right, so here are the answers to 4 and 5. I just went with the plugging in the substitution method, and I just substituted 5 in for every x, and I simply just used a calculator to find the answer. So both of those evaluated. Number 4, you should have gotten -5, and 5, you should have gotten -10. If you did synthetic substitution, you still would have gotten those same answers. All right, let's move on. So my next question, question 6, says identify the key features of a polynomial below. Graph if the graph is not provided. Well, here I give you a graph. So the zeros are the points where it crosses the x-axis. So when you figure out your answer here, you're looking for places where it crosses the x-axis. Relative maximums are places where the graph changes from increasing to decreasing. It almost looks like the letter N or an upside down U. Relative minimums are where a graph changes from decreasing to increasing. And again, those will look like a U. Increasing intervals are described in terms of x for where the function is either increasing or decreasing. And then lastly, end behavior. What are the arrows? I know you don't see any on this graph, but if we were graphing, we'd put arrows on there. What are those arrows doing as they go left and right? So pause the video again, give number 6 a try, and then when you press play, the answer will be revealed. All right, so let's look at these key features. Here's the answer to number 6. The zeros, or the x-intercepts, there are 3 of them. One at -2, one here at 0, and one here at +2. The relative maximums, that's where a function changes from increasing to decreasing. That's right here at 0, 0. So the point 0, 0 is a relative maximum. I have 2 relative minimums, and if your decimals are slightly different, that's okay. We're just approximating. That's where the function changes from decreasing to increasing. So here, this u. And then this u over here, it changes from decreasing to increasing. So those are 2 relative minimums. They define really my intervals of increasing and decreasing. So I'm going to go ahead and read this from left to right. So as I come in from the left, like if I get on this roller coaster, I start going down. And I go down until I reach this minimum. So at this minimum, that looks like -1.5. Yep, it is. So from negative infinity to -1.5, I am decreasing. And over here, if you look at my decreasing intervals, there's that first one. And then at -1.5, again, this is an x value. The word increasing and decreasing describes what y is doing. So here at -1.5, I begin to increase until I get to x is 0. So if you look, that's my first increasing interval. And then at 0, I switch to decreasing until I get here to 1.5. So that's my next decreasing interval. And then finally, from 1.5 to infinity, I am increasing again. For end behavior, that's where we describe, well, what's the left arrow doing and what's the right arrow doing? So the left arrow obviously always goes left forever. So as x goes to negative infinity, we need to decide what's y doing. And well, y is going up. So as x goes to negative infinity, y goes to positive infinity. And in fact, the other side's the same. As x goes to the right to infinity, y is also going up to infinity. Let's look at the next ones we have on the review. All right, so the next ones we have to classify as even, odd, or neither. So an even function is a function that the highest exponent is an even number. So to the 4th, or to the 2nd, to the 6th, to the 8th. In terms of a graph, we talked about in class, those functions always have end behavior that are either both pointing up, so both arrows are pointing up, or both are pointing down. For odd functions, that means the highest exponent is an odd number. And in terms of a graph, that means the end behaviors are opposite, meaning one arrow is pointing up and one is pointing down. So go ahead, give 7 through 10 a try, and then press pause, give 7 and 10 a try, and when you press play again, the answers will be revealed. So here are my answers to 7 through 10. So this first one, number 7, is even because both arrows are pointing up. 8, this graph is odd because both arrows are pointing in opposite directions. Or sorry, the arrows are pointing in opposite directions. Number 9 is odd because the exponent is odd, or the degree is odd. 10 is neither. That's not even a polynomial because of the negative exponent. All right, let's look at the next ones. The next 3 are all properties of exponents. So remember, if you're multiplying, you add the exponents. If you're dividing, you subtract exponents. If you distribute exponents, you multiply. So give 11 through 13 a try. Press pause. When you press play again, the answers will be revealed. All right, here are your answers to 11 through 13. I kind of showed my steps, or I tried to. So the first thing I had to do in 11 was distribute the 2. So that meant this became 2 squared, which is 4. And when I distribute, I multiply little numbers, so that became u to the 6th. And then I treated numbers like numbers. 2 times 4 is 8. My v's, I had v to the 1st and no other v's, so there's just a v to the 1st. And then my u's, I had u to the negative 1st times u to the 6th. If you multiply, you add those exponents, so that gives me u to the 5th. In the next one, I started here on the bottom because I saw I had common bases. I have x squared times x. Well, that gives me x cubed. And I had y times y to the 3rd. That gives me y to the 4th. And then now I notice I can divide. I have x to the fourth over x to the third. When we divide, we subtract exponents. So this 4 has the power. I subtract 3 up from 4, and I get x to the first. And everything else stay the same. In the last one, in 13, I begin by distributing the 4 to the 2 and the 4 to the x to the fourth. So that 2 to the fourth gives me 16. X to the fourth gives me x to the 16th because I multiply. And then now I see my x's I can subtract. Well, 16 has the power, so I'm going to subtract 16 minus negative 4 into the bottom. That gives me x to the 20th. And I also notice I cannot have negative exponents, so I need to flip that guy into the bottom. So there is my final answer for 13. Let's look at the next two. All right, next 6 are orders of operations with functions. So adding, subtracting, multiplying. I'm going to just show you, pause the video and try them. There's not really much explaining to do for these guys. Adding, subtracting, you just combine like terms. Just subtracting, make sure you distribute the minus first. And then I think we all remember how to FOIL and distribute. The only trick, maybe in 18, if I want to cube x minus 3, if I want to do x minus 3 cubed, I have to do x minus 3 times x minus 3 times x minus 3. So pause the video. When you press play again, the answers will be revealed. All right, here are your solutions, 14 through 19. Just pause the video if you'd like to check. I'm not going to spend a whole lot of time explaining because, again, these are pretty easy, or they should be pretty easy. And I did show quite a bit of work. Maybe, again, I'll stress 18 before I move on, that x minus 3 cubed means I have to multiply that by itself 3 times. So if you look at my steps, I started out by multiplying the second 2, and then I multiplied in the third. Let's see what's next. I think the last one here is a word problem. The length of a rectangle in terms of x is 3x squared plus 7x plus 9, and its width is 3x plus 6. What is the perimeter of the rectangle? So my little help here for you is I would draw a picture of a rectangle, and I'd label the length, and I'd label the width. And then I would think about, well, what is the formula for perimeter? Area is length times width, but I want perimeter. So perimeter is when you add all of the sides. So I add both lengths and I add both widths. Or you could also just multiply one the length by 2 and the width by 2 and add those. So pause the video, give it a try. When you press play again, the final answer here will be revealed. All right, here's the answer to the last question. Again, I drew a picture, so there's my rectangle. It's not great, but we'll say it's a rectangle. I labeled my length and width, and then I chose to do the sum of the 4 sides. You also could have done 2 times the length, distributed a 2, and then added that to 2 times the width. Either way, you should get the same final answer.